Hello and welcome to Flash Forward. I'm Rose and I'm your host, and Flash Forward is a show about the future. Every episode, we take on a specific possible or not so possible future scenario. We always start with a little field trip into the future to check out what's going on, and then we teleport back to today to talk to experts about how that world we just heard might really go down. Got it? Great. This episode, we are starting in the year 2055.
Dr. Pastrana, hi. Do you have a minute?
Sure, of course.
I think I know what I want to focus on for my thesis.
Oh, good. I was starting to worry about you.
Yeah, I just have a lot of interests, I guess.
Not always a bad thing, but sometimes a bad thing. So, what are you thinking?
I really love the guest lecture that Dr. Minowan did a few weeks ago, and I've been doing some of my own research into it, and I think I want to look into this question of Bronze Age cultural changes across Eurasia, especially language changes. It's so interesting to me that we just don't know what caused these. Did the ideas move, or did the people move? But that seems like a question we could totally answer. We just have to do more work on the DNA, right? I don't think there's a big, broad comparative study that samples across all of Eurasia to understand how human DNA moved over time. It's actually really weird that there isn't a study like that, honestly. But I thought maybe that's what I could do.
Yes. You're right that there isn't a study like that.
Which is good for me. I could do it, and it would be a real contribution to the field.
Well, there's a reason there's no study like that. Unfortunately, there's really no way to do that study.
Why not?
As you said, you'd need a broad set of samples from the time period, and we just don't have them.
What do you mean we don't have them? I've read a ton of work from the 2020s on Bronze Age DNA.
Right, and have you noticed that there hasn't been much published on that time period at all recently?
Yeah, it seems to stop around 2029.
Why do you think that is?
I don't know. There are always trends in what research is considered sexy and what isn't.
That's true, but that's not what's happening here. You stumbled upon a sort of dirty secret in archaeology. For a long time, our sampling methods were destructive. To get DNA, we had to grind into the bones. And when the boom in archaeological genetics happened, everybody got excited. Everybody was doing all sorts of really interesting work, and nobody was really keeping track of how much was being used, until it was kind of too late. Bronze Age stuff was really popular to work on, and the samples that we still have intact are totally spent. There's nothing left to extract from them.
So what do people do if they want to study this stuff?
They find other ways.
Could we find more remains?
Possibly. I'm sure there are places we haven't looked, but most of the remains in those places would rightfully, of course, go directly to the indigenous people there. So if you did manage to find new remains, you'd have to convince them to help you.
Well, how does Dr. Minowan do his work?
That's a good question that many of us would love the answer to. He has an exclusive contract with the Green Museum, and they have a few samples remaining. But I've also heard... Actually, never mind. I shouldn't spread rumors.
I won't tell anyone. Come on, you can't totally destroy my project idea and dangle a rumor in front of me without giving me a little more? It's just not fair.
Here's what I'll say. Dr. Minowan is often an expert witness in repatriation cases. His brother is the leading lawyer for those cases in the Balkans. If you want a body back, you go to him. And maybe, before the body goes back, there's a little pit stop at a lab for some sampling. That's the rumor. I obviously have no idea if it's true or not.
So if I want to do this study, I have to talk to Dr. Minowan.
He's not known to share.
So we just won't know more about this time period at all, basically?
No, that's not true. We just won't know about them through genetic analysis of the type you're hoping to do. There are plenty of other ways to study a time period or a group of people.
Past humans sucked, huh?
Yes, so do current ones. It's kind of part of what makes us human, I think. For better or for worse.
So today we are talking about the future of archaeology, and specifically the future of research into ancient humans and our close relatives like Neanderthals. And one of the best ways to understand these ancient creatures is by looking at their remains.
Using human remains for analysis is really important because it allows us to kind of connect with our deep past, like really deep.
This is Dr. Keolu Fox, a researcher at UC San Diego,
Where I am affiliated with the Departments of Global Health, Anthropology, and the Indigenous Futures Lab.
To connect with our deep past, archaeologists who study our long-dead ancestors use a whole suite of tools to analyze and piece together information from the bones they left behind.
And there are various techniques to do this. There's sort of like bone morphology stuff. There's a bunch of kind of tissue identification stuff. And the, radiocarbon dating, of course.
And then, about 10 years ago, a new tool was added to that toolbox: DNA. In 2010, scientists sequenced a piece of the Neanderthal genome for the first time. And that was a huge deal. Today, there's kind of an ancient DNA gold rush happening. Scientists have so many questions that they want to answer using the DNA of these ancient people.
I am personally really interested in comparing genome sequence data derived from ancient genomes to modern genomes and using those cross sections in time to understand ideas around human genetic diversity. So one thing I'm really interested in is understanding the sort of genomic diversity that might exist in pre-contact indigenous communities, and then the effect of the arrival of European pathogens via colonialism, and how that affects population structure and how that causes a population collapse.
Using ancient DNA, researchers can explore things like how early humans moved around, the kinds of diseases they had, and even which ancient humans interbred with Neanderthals. But there's a catch. Extracting DNA from these ancient bones is not easy.
DNA is not just accessible in the same way it is in living modern humans. You have to think about like the weathering process and the way things deteriorate and degrade. DNA itself is sort of like a polymer or a ribbon, and these chemical bonds degrade over time.
Over thousands of years, these bones decay, and the DNA inside of them breaks down. At this point, most of an ancient skeleton isn't going to have DNA in it. There are only certain places, deep inside and protected from those weathering forces, that are likely to still contain usable genetic material. Teeth are great candidates, for example, because the tooth itself protects the material inside. And there's one spot in the human body that's even better.
There's a part of the human skull called the petrous bone, which is sort of like this little gyroscope or onion almost in a way, in that it has like layers of bone around it that protect this petrous portion, which is a really good place to get DNA. So that becomes coveted because you know that if you can basically crack open a human skull and get access to this petrous portion, then you're going to have a really high chance of having good quality DNA to be sequenced.
The petrous bone is kind of like the hidden gem of every ancient skeleton, at least when it comes to DNA. In some cases, scientists have been able to extract 100 times more DNA from the petrous bone than from any other part of the body. But it's also a pretty small bone, located deep inside the skull. To get to it, you have to drill through what's called the cranial vault, and to extract DNA, you have to grind a piece of it into dust. And some researchers, like Keolu, are starting to worry that in all the excitement around the possibilities presented by ancient DNA, the field might accidentally blow through the specimens they have.
More ancient genomes had been sequenced in the first 10 months of 2019 than the entirety of history.
Yeah, and is anybody keeping track of these samples in terms of who's using them, if they're being overused, if certain samples are at risk? Like, is there any kind of like record keeping here?
That is a great question. To my knowledge, there isn't much of a system for record keeping. You will hear about it when experiments work because they will be the mainstay featured on a marquee journal like Science or Nature. You know, Neanderthal genome, Denisovan genome. But no one really talks about the negative results, i.e. how many attempts did you or experiments did it take for you to get to the point where you can talk about this data?
This point about negative results is a huge problem in almost every field of science. Studies only get published when your experiment works and you find something out. But most experiments don't work. Most of the time, stuff doesn't turn out the way you wanted. And all those times you tried and failed, nobody really knows about them except for you and your lab mates. And that can cause not just duplicated efforts because people aren't sharing the stuff that doesn't work with one another, it can also obscure the amount of material that's actually being used. In the case of archaeology, you might publish a study on one bone, but you actually tested 5 to get there that aren't mentioned.
So no, there isn't really a good system for understanding what is held where and what is being destroyed and who has access to what and what is its provenance and where was it from 1921 to 1945 and so on and so forth. So we really need to build those types of systems.
Last year, Keolu wrote a piece with Dr. John Hawkes for Nature, sounding the alarm and calling for the field to think a little bit more carefully and a little bit differently about the ways these studies are done. Without a change in course, Keolu argues that we could be headed towards a really sad future.
I see one future where this is really dark and we run out of this finite resource. And that's highly problematic because what we really need is a bit more patience. We need patience because this paleogenomic industrial complex that is currently operating right now would benefit greatly from a recalibration.
And archaeology has done this kind of thing before. In the early days of the field, it was a lot more like looting than science. Entire tombs and regions were stripped clean, and artifacts were damaged or removed from their context or just lost. Even more recently, in the 1990s, pretty big sections of ancient human skeletons were destroyed for radiocarbon dating. If they had waited just a little bit longer, the techniques would have advanced and they could have destroyed much smaller pieces and left more behind for future researchers. And it's not just about being more careful with the specific techniques they're using. Keolu also sees this question of resource management as a question of who is doing this work and to what end. When we spoke, Keolu pointed out that only a handful of labs are getting access to a lot of these samples.
And that's just really a dangerous, dangerous idea. If only a handful of laboratories get to interpret that information and basically repatriate the deep past of our whole species, right? There should be more of a consensus building process in the way that we understand that information. So if it's all white European males that are interpreting the history of our whole species, then who do you think that's going to serve? That is another kind of ominous and dark future in that there are a lot of mistakes that are made in the way that we design algorithms and the way that we interpret digital sequence information. And if that isn't a process where we involve more stakeholders, then that's only going to serve, one community of people. There's the we don't know what we don't know, and then there's the I can intentionally erase large bodies of our history and recreate them in a way that suits me. That's super dangerous.
So how do we avoid this future? Well, for one thing, Keolu proposes that large institutions, like the Smithsonian, should link up and try and keep track of who is using which remains for what, to try and get a better, high-level picture of the overall rate at which researchers are going through this precious material. And he also thinks that it's time for archaeology to really fundamentally rethink a lot of how it functions, the questions it asks, and who it serves.
Whose questions are we asking? How are we interpreting this data? Who is making the comparisons and really designing the algorithm to think about the way we use ancient genomic information as a resource? It's so important to understand the mistakes we've made in the past so that we kind of recalibrate and correct course. We have this saying in Hawaii, "Ikawama mua, ikawama hope." We're walking backwards into the future. We're recognizing all of our history of mistakes that we have made in order to form a healthier future, in order to really provide opportunities to recombine new technologies in novel ways, right?
What that means for ancient DNA sampling specifically is for the research community to really think about which questions get priority, and whether you actually need DNA to answer them.
No one has ever asked the community what their priority is and what those questions are. I don't think the scientific community broadly has enough imagination to actually source questions from the indigenous communities that they're working with, the modern descendants that they're working with. I can assure you that if they were to do that, the papers would come out a lot stronger, and they would get a lot less kickback from the communities that they're treating like, baseball cards at this point. For example, there was a recent paper that was published in Nature, and they showed, using kind of genome sequence or array data, that Polynesian people made it all the way to South America. Now, if you're Polynesian and you know our history and you know all of the other lines of evidence, including, but not limited to, linguistic data, flora and fauna genomic data, and archaeological data and local history data, you would know that it's well validated and pretty much already been proven that if you had a mastery of voyaging and navigational technology, so much so that you found Hawaii and the Marquesas, then why would it be hard for you to identify a whole continent in South America? You would find it. It would not be challenging at all. So to kind of go back to the well and reinvent or resell a narrative that has already been proved in a lot of different ways using genetic data, it's not in service to the holistic approach of science, right?
If these petrous bones are a super rare and valuable resource, is it really worth grinding them up to answer questions that you might be able to answer in other ways, that might have already been answered in other ways by other people and other sources of data?
The version of science that we're thinking about within the paleogenomics space really has to do with this recalibration, where it's more about growth towards cultural sustainability and involving more diverse stakeholders and not maintaining the status quo, because the status quo is harming indigenous communities and their ancestors.
A couple of weeks ago, we talked about the idea of decolonizing data, of talking to the community about what they need to know and how they might want to find that out, and how the data should be gathered and stored. Keolu is working in that very same vein, hoping to balance out the power between the subjects of research and the researchers themselves.
And so what I would like to see more of is allowing communities to prioritize the questions we ask and co-hypothesize and co-develop and not co-opt ethics in a way to get access to ancient remains, but actually genuinely, authentically authentically build projects that serve the communities, that actually have impact in the communities, that help them repatriate their deep past and strengthen their identity today, and most importantly, carve out a brighter and healthier future for them and their descendants.
And Keolu thinks that this wouldn't just impact archaeologists who study ancient DNA, a small but mighty cohort of people. Instead, his work at the Indigenous Futures Lab is hoping to take this same approach to lots and lots of places and make some big changes in the broader culture.
Listen, cultural sustainability is good for everyone. When we talk about diversity, it's good for everyone. When we talk about equity, it's good for everyone. And in this space, that's no different. When we allow for a new space and a new perspective and prioritize questions that are not just like locally specific to the knowledge, but really engage the community in this kind of iterative process of honing in on better and better questions that could help us think about the past in new ways. Now we're talking about innovation. Now we're talking about some seriously new questions that we've not even approached before, that we can't even imagine. And that's the future that I would like to see. That's what we're trying to build here at the Indigenous Futures Lab, are ways to empower our communities so that this science actually has an impact in a sustainable way, whether it's related directly to climate change and sustainability or cultural sustainability. That's what we're trying to build here.
Most archaeologists aren't, cackling while they grind up human bones left and right. Most people in the field recognize that the choice to do destructive sampling is a really serious one that should be considered carefully. And compared to other methods, like radiocarbon dating, DNA sampling isn't even the most destructive. But what would happen if we sort of stumbled into a world where all those little petrous bones on the human remains that we do have been ground to dust? Well, it turns out there are some really interesting other ways to get information about humans. And when we come back, we're going to talk about a few really cool future archaeological methods that don't require destructive sampling at all.
Yeah, there's absolutely quite a bit of skepticism, and it still seems sort of like magic.
But first, a quick break. Okay, so let's say that the gold rush of ancient DNA research continues and suddenly future researchers, like the one you heard in the intro, find themselves without specimens to sample. What happens next? Well, one thing you could do is try to find more samples. There are certainly more humans in the ground than we have found so far, but that is easier said than done. Even in places where researchers know early humans lived, they can't always find bones. But what if I told you you didn't always need human remains to find human DNA?
We have an analysis that I hope should be coming out soon where we really, I think, have done great things, or really interesting things, trying to elucidate the histories of Neanderthals from sediment DNA. It's, to me, still sort of magical.
This is Dr. Benjamin Verneau, a researcher at the Max Planck Institute for Evolutionary Anthropology. And Benjamin's research has recently focused on sampling and analyzing human DNA that comes from the Earth. Like literally the Earth, the sediment, the soil, the dirt in the ground. Where is that DNA coming from?
Yeah, that's a really excellent question. And to be honest, I don't think we really know. I think that one can speculate quite a bit and make some educated guesses. So when you find DNA in a cave, the majority of what you find is, say, bear DNA from animals that maybe didn't die in the cave, but could have left large amounts of feces or hair or urine. My best guess is that it largely comes from poop.
Nice. So wait, you might be wondering, as I was, how this is possible. Why is it that an actual human skeleton from 40,000 years ago degrades away and doesn't have usable DNA, but it's just, in the dirt somehow?
There are actually some things about sediment that lend themselves to DNA preservation. So we largely think that even in bones that the DNA attaches itself and is preserved to a certain extent by the mineral elements in the bones. And so, sediment is minerals, right? And so we think that it attaches itself to the minerals in the sediment and is possibly preserved there as well.
Researchers were first able to do this kind of analysis in 2003 when a scientist named Dr. Eski Willerslev was able to get DNA out of a core from the Siberian permafrost.
And there they mostly got DNA from plants from permafrost and were able to sort of look at turnover of different plants over time.
From there, the technique extended out to other non-human animals.
So there was a paper from 2009 where they were able to show that horses and mammoths survived in Alaska for much longer than had previously been thought.
And eventually, they got it good enough that they could actually start to find human DNA in these soil samples, often in places like caves that we know people lived in.
So the best situation, sort of the optimal situation for us, is a previously excavated cave that has a face, right, like a wall that has exposed a bunch of layers where there's already archaeological evidence that there were people there, and then you sort of honestly, you just stick a tube into the wall and twist it, and a little bit of dirt falls into the tube, and you move along to the next spot.
Once you have the dirt, you then have to make sure that you are actually sampling ancient DNA and not stuff that might have been left behind by more modern humans who've been in the cave more recently. And to do that, they basically look to see if the DNA has degraded in the way that they expect.
And you can look for those patterns in the DNA, and if you don't see those patterns, right, if you don't see this particular base breaking or mutating or being damaged at sort of the frequency that you'd expect it to be, then you can really tell quite clearly that it's not ancient DNA. And that degradation does complicate your analysis, right? Because you're essentially, you need to have evidence of crappy DNA in your sample in order to believe it. But then when you have crappy DNA, it makes it more challenging to analyze. And that's why this field is sort of interesting and challenging at the same time.
But even with that crappy DNA, you can get legitimate results that tell you about these ancient people. This is absolutely incredible to me. 50,000 years ago, some early humans pooped a bunch in a cave, and now we can sequence the DNA left behind and learn about them even if they didn't leave their bodies. Most of the time, this is data that tells us about a population, not an individual human that might have lived in the cave. But that's often what researchers are looking for anyway. They want to understand how different populations moved around and whether they bred with one another, when they arrived, how long they lived in a place. And right now, there is some really exciting work going on in this field to answer some of those questions. A lot of it so new that Benjamin actually can't tell me about it.
To be honest, I don't know exactly how much to say because I think there are really cool things that are going to happen, but they're all not published yet. Sort of confidentially, so.
I know, I'm trying to goad you into revealing your secrets. So just to be clear, Benjamin is not keeping this a secret for any nefarious reasons. In science, there's this weird rule called the Inglefinger rule. Yes, that is indeed what it's called, where you are not allowed to talk about your research until it is published in a journal. Otherwise, that journal could decide to pull your study. Whether that is actually a good rule is a topic for another podcast. But what this really means is that there is some really exciting stuff that is about to be published on this topic. And the idea that there might just be DNA laying around in the dirt everywhere, just waiting to be analyzed, is really exciting.
Maybe this is totally out there and bizarre, but I will say that reading about this and talking to you makes me want to just go out in my backyard and dig a hole and be maybe there's some DNA down there.
Yeah, I mean, probably not in California, but I think that, yeah, that's absolutely something that I have thought of. We have a small garden, and I oftentimes want to just dig up some dirt and see what sort of DNA is in it.
Have you not done it yet, though?
No, I have not. I'm not allowed in the lab, and so it's a little bit, it would be challenging for me to enact that dream.
Why are you not allowed in the lab?
Oh, I'm sorry. That's a joke. I'm a computational person, and so I don't...
It's after the incident last year, not allowed
right,
back
exactly.
in there.
Yeah, well, ever since the big fire, no.
But before we get too excited, it's also worth considering a couple of questions of ethics and DNA collection with this method. If I were to go out into my yard and dig a hole and find an ancient body, I would be legally and ethically mandated to figure out whether there are living descendants of that person. This is a big topic in research in archaeology, making sure that you are respectful of the remains that you're dealing with. When we're talking about Neanderthals from 50,000 years ago, this isn't really an issue. There's no one living group today that makes sense to say is a descendant. But when you're talking about more recent remains, this is a big question. And when you're just finding DNA in soil as opposed to bones, it gets kind of complicated.
The situation that I can imagine is someone comes and they take sediment from an area where there's a Native American tribe that owns or used to own or should own that land. And someone takes sediment from it and gets DNA from it and then publishes findings sort of about those groups of people and doesn't feel as though they need to engage that group of people in the same way that they would if there were bones, right? That they would legally have to if there were bones even. And so, I wouldn't want that to happen, right? I would hope that this is still DNA from a group of people. I think that one should still try to be conscientious about that. So, yeah, I think it's an important question, and I hope it's one that people don't just see sediment DNA as sort of a loophole or a workaround.
Last year on an episode, we talked about the DNA that people leave behind at a crime scene, or even just at a police precinct, which is kind of similar. Right now, the US legal system considers DNA that you might leave on a doorknob or on a chair that you sat on the same way that it considers your garbage, which means that you don't have any right to it. The law does not protect it. But as we said on that episode, that's kind of weird, right? You're not choosing to throw away your DNA. You have no choice in the matter at all. You can't control it. And the same questions arise here. These ancient humans didn't choose to have their DNA bound up in the soil. And these are questions that this field is going to have to grapple with. This method is still really new, and the DNA that comes out of the soil is often not that good. There are tons of improvements that Benjamin would like to see. But it's also a really exciting time.
I mean, when you talk with archaeologists about this, I've presented this at a few conferences, you can see in their eyes sort of this dirt is a resource, right? So I think that the ability to do time transects, right? Like really detailed time transects of sites with one or two or no bones is going to be really great.
And this method could also help us understand what was happening in places that are really hard to study, like underwater sites.
There's quite a bit of the Earth that was accessible to human habitation and maybe would have been preferential because it was close to the shore that is now underwater. In my dream world, we would be able to get marine sediments and get ancient DNA from them.
But it's not just DNA techniques that are getting really exciting. There are also some really amazing non-destructive methods that are changing the future of archaeology. If you think getting DNA out of soil seems like magic, buckle up. It is about to get even more mind-blowing. But first, a quick break. Okay, so these ancient DNA techniques are really cool and are getting more and more sensitive over time. But DNA isn't the only way to understand an ancient population. And the future of archaeology is not just DNA evidence.
We are prioritizing genetics as a line of evidence over every other line of evidence. And that is really problematic because, archaeological data exists, linguistic data exists, ethnographical data exists, local histories exist, and sometimes these are sufficient for answering the questions that we want to answer and understand. A lot of what happens is this colonial perspective of, I'm going to sequence this genome because I can.
That's Dr. Keolu Fox again. There are so many other ways to learn about ancient humans that don't involve grinding up bones to do DNA sequencing.
I do feel like the DNA aspect, it's kind of like a sexy topic. And now that we have the capability to sequence DNA from humans tens of thousands of years old, we want to do it because we want to know what's going on. From my point of view, it's kind of a shame that some of these other methods for assessing ancient humans don't get as much attention when they might be just as interesting or maybe even more interesting. I mean, I guess it depends on the person, right?
This is Dr. Naomi Martitius, a postdoctoral researcher who also happens to work at the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany. And Naomi studies the Paleolithic.
Often I'm studying humans at about 40 to 50 or maybe even longer, 1,000 years ago.
And more specifically, Naomi often looks at the tools that ancient humans and our close relatives, Neanderthals, made out of bones. Finding these tools is really hard, and they're really rare, and usually you're finding pieces of them, these little precious shards. Which means that Naomi does not do destructive sampling on them.
So if it's you only have a couple of this particular type of bone tool, probably don't want to destroy it because maybe there's some sort of technique in the future that will become available where you don't have to actually destroy it to learn the same thing that you were going to learn.
And one of the really cool, recently discovered non-destructive methods out there, at least in my opinion, is called zooms.
Should I just say it right here? Zooms or zooarchaeology by mass spectrometry.
Zooms is not trying to gather DNA. Instead, it's a method of sampling and analyzing collagen, a kind of protein. Collagen is the most abundant protein in the body of mammals, and it can be found in skin, tendons, in your eyeball, all over the place. And if you gather the collagen from a sample, you can tell a couple of things about it.
From the mass of the peptides that are found in the sample, you can then tell what species, or sometimes you can't even get to specific species, but you can get to a group of species, like a family of animals.
One of the really cool applications of zooms has been in the analysis of parchment samples, writing material made out of animal skins. If you want to know what kind of animal that parchment was made of, you can often use zooms to figure it out. A couple of years ago, a team at the University of York developed a really incredible way of doing this, gathering up collagen from a parchment without having to snip off a piece of it. Instead, they simply used a little eraser and rubbed that eraser on a corner of the parchment.
From that analysis, it was proposed that what was happening was, as you rub the eraser on the parchment, the interaction of the eraser on the parchment causes like this static electricity. And so what's happening is the plastic from the eraser is pulling out the oppositely charged collagen molecules from the parchment.
From there, the team wondered what else might have enough static electricity to pull tiny bits of collagen out of a sample without damaging it. And they tried testing the plastic bag that a few bones had been stored in.
When you curate a bone in a bag, there is some rubbing happening in there anyway. If you're just like carrying the bag from one room to the other, there's something happening. The bone is moving. So the idea is that the plastic in the bag is then pulling out the collagen from the bone.
And incredibly, this worked. They were able to get positive results just by sampling the container that a bone had been stored in. A couple of years ago, Naomi saw a presentation by this University of York team about this method and decided to try it herself on a few pieces of Neanderthal bone tools in her own work. Now, it was not a given that this would work because the York team's experiment was on much younger samples than the ones that Naomi handles. So she wasn't sure if this would actually give her positive results.
Was there ever any debate about whether to even bother trying this for you? Because it's so much older.
I mean, not really, because maybe if it was a super expensive method, then, we might think twice about that. But doing this type of analysis doesn't really cost that much. And because it is non-destructive, it's not costing the artifact much either, right? Just like, why not? Why not just go ahead and try it?
So they sampled the plastic boxes that the bones had been stored in, and for 4 of the 5 samples, they got positive results, which, this honestly feels like magic, right? You just swab the box that the stuff was stored in, and you can tell what species the bones came from? Personally, my mind is blown. And in fact, I am not the only one.
Yeah, as far as I'm concerned, that actually is magic. I don't know.
And the extra cool thing about this is that the results they got give us new insight into Neanderthals and their ways of thinking. So the specific samples that they did this study on were on these tiny pieces of Neanderthal tools.
Neanderthals made some bone tools out of animal ribs. And when we first looked at them, because they're so small and fragmented, and also they're made out of ribs aren't that distinct. It was really hard to tell what animal they came from.
3 of the tools that Naomi used this method on came from a time when it was really cold, and the main large animal species around were reindeer. So researchers had assumed that these bone tools were likely made from reindeer ribs. But what the Zoom's analysis found was that these tools were not made from reindeer. They were actually made from either bison or auroch, which is a now extinct cattle-like animal. So even though the Neanderthals were hunting and seeing reindeer way more often, they chose to make their tools out of bigger animals like bison.
So whenever these Neanderthals happen to hunt a bison, come in contact with them in some way, it seems like they took those ribs from those animals and utilized them for their tools, which is pretty neat.
That suggests that Neanderthals knew the properties of the material they were working with. The ribs of bison are bigger and more rigid than the ribs of reindeer, which make them better suited for these tools.
So Neanderthals made and used these tools, and I have no idea what your opinion is about Neanderthals, but I think often in popular media or just in the general, I don't know, zeitgeist or something, Neanderthals are often portrayed as, I don't know, brutes that are stupid and don't know much, I don't know, dragging women by the hair or something. And I think that's, that's an old antiquated view of Neanderthals. And the more and more that we learn about them, we realize that they were doing very, very similar things to people.
And all of this insight came without a single speck of DNA.
It's kind of like a puzzle, trying to build this story from, teeny tiny fragments of bone or stone or whatever it is, to try to understand how these people lived and what they did in the past. It's not just about who they were, right? It's how they were living.
And the future techniques of archaeology, they will likely involve all kinds of really interesting sampling methods, some of which will include DNA and some of which will not. And at the same time, even the methods that are destructive are getting better and better as well, getting less destructive, basically. In the future, we might be able to get all kinds of information without actually taking a skeleton out of the ground at all.
Ground penetrating radar, I think, is something really cool to use. We could speculate on where that might go or improvements to methodologies using that. Maybe at some point you won't even have to dig, if that particular type of method gets so good. You can see individual artifacts in the ground.
And really, the future of archaeology is all of these things. It's using all these tools to create a complete picture of what was going on with our earlier ancestors.
The coolest ancient DNA studies that have come out recently are ones that incorporated a bunch of other additional information in them, right? That were not just about the DNA. Each of these things has its strengths. The DNA is really good at elucidating broader population relationships and very specific familial relationships, right? You would never be able to say this is this person's nephew without the DNA, unless this Neanderthal was buried with a will or something like that.
That would be a pretty big discovery.
That would be the paper of the year for sure. So I really think that to me, it's the exciting stuff in the field is going forward, sort of merging all of these technologies, all of which are getting better all the time.
The graduate student you heard in the intro could invent some new technique we haven't even thought of yet, some way of exploring our human past that nobody had considered. And if all of this feels like magic to you, which it certainly does to me, think of how it might seem to a Neanderthal. Sure, they were smart making their bone tools, but I bet they would be pretty impressed by all of this. And in 50,000 years, if humans are still here studying our remains, I bet the tools that they're using would absolutely blow our minds too. Flash Forward is hosted by me and produced by Julia Linus Goodman. Hooray! I am so excited to have brought Julia on, and supporters got to hear from them on the bonus podcasts this week. Longtime listeners know that this is the first time I have had any help making the show in 5 years, so it's very exciting. And that's only possible because people donate to the show. So if you want to support the show and keep it growing and maybe make it possible for me to bring Julia on for more than just part-time or hire other people, you can figure out all the ways to do that at flashforwardpod.com/support. And that gives you a bunch of options for how to kind of give a little bit to the show to keep it going and to keep people like Julia on the team. The intro music is by Asura, and the outro music is by Hustleonia. The episode art is by Matt Lubchansky. The voices from the future this episode were played by Ashley Kellum and Henry Alexander Kelly, and you can learn more about them in the show notes. Please do go check that out. They have really cool projects. If you want to suggest a future that we should take on, send us a note on Twitter, Facebook, or by email at info@flashforwardpod.com. We really do love hearing your ideas. Some of the upcoming episodes are ones that people have recommended, so I really do read every one of them and consider adding it to the list. And if you think you've spotted one of the little references that I've hidden in this episode, email me there too, info@flashforwardpod.com. If you are right, I will send you something cool. And if you want to discuss this episode or some other episode or just the future in general, you can join the Flash Forward Facebook group. Just search Flash Forward Podcast and ask to join. There is a question you have to answer. You have to answer it. If you don't answer it, I will not let you in because you may be a robot or something. I already mentioned that you can support the show by going to flashforwardpod.com/support, but if financial giving is not in the cards for you right now, there are still other ways that you can help Flash Forward. You can go to Apple Podcasts and leave a nice review, or you can just tell your friends about the show, tweet about the show, put us on Instagram or TikTok if you know how to use that, which I have been trying to learn, and man, it's harder than it looks. Anyway, all that stuff really does help. That's all for this future. Come back next time and we'll travel to a new one.